In 1988, a Boeing 727 took off over the Mojave Desert for a test flight. If you look closely at the tail section, you'll see a strange, entirely exposed engine. This chart compares standard 1980s fuel consumption against that strange engine known as the GE36. The test flights confirmed a massive 30% drop in total fuel use. Engineers saw these test results and began designing a whole new generation of aircraft around the open rotor. Millions of dollars flowed into the design. High-level government test flights successfully verified the data, and then the entire project completely vanished. The test data, the physical prototypes, and the detailed blueprints were quietly locked away in corporate and government vaults for decades. Why did the aviation industry deliberately choose to bury its most efficient technological breakthrough? To understand the mystery, we have to look at the physics of the bypass ratio. Look at the fan blades of a standard modern jet engine. Notice how they are tightly constrained inside a thick metallic casing. This diagram shows a cross-section of that standard engine. You can see how the airflow vectors get choked by the outer walls, or the nacelle. That heavy outer casing physically limits the total volume of air the blades can process. The Propfan design solved this by stripping the outer casing away entirely. By leaving its curved carbon fiber scimitar blades completely exposed, the engine could instantly pull in a massively expanded volume of air. This unconstrained airflow provided a leap in efficiency that standard turbofans simply couldn't reach with their existing geometry. The engine pushes more air with significantly less effort. Engineers had optimized the air volume, but they discovered a second, much louder problem hidden in the physics. Those exposed blades generated violent, destructive sound waves. During real-world testing, the acoustic data was overwhelming. Pilots and engineers described the deafening roar as a literal chainsaw in the sky. This structural flaw emerged right as global oil prices suddenly crashed in the late 1980s. The immediate financial pressure to save fuel disappeared. Airlines and manufacturers weighed the data and made a collective compromise. A 30% reduction in fuel costs simply wasn't worth the thousands of unbearable noise complaints they would receive from passengers and the cities below. The technology was deliberately shelved. In the 1980s, the world chose quiet comfort over green efficiency. Fast forward to today. The economic and environmental landscape has shifted. Emissions targets and fuel prices have changed the math for airlines. The desperate, pressing need to radically cut aviation emissions is forcing engineers to reopen those forgotten NASA test vaults. This is the modern successor. Aerospace companies are now developing new open rotor designs that utilize sweeping, advanced scimitar blades. But this time, engineers are using 21st century aerodynamics and complex computational modeling to successfully silence those destructive sound waves. With the acoustic flaws ironed out, this resurrected technology represents the only viable mechanical blueprint capable of saving the next decade of commercial flight. The GE36 was a mechanical success. It just flew in an era that wasn't ready to pay its acoustic price.